So welcome. This is a video based upon differential calculus, some questions from past paper questions and some exercise questions based on the topic differential calculations on the differentiation. So the first question we may try to write it out. Use L'Hopital's rule. Use L'Hopital's rule to simplify or find the value of what is that? Limit x approaches 0 2x cos x square upon 5 tan x. So for L'Hopital's rule, what am I supposed to do? Find the derivative of the numerator divided by derivative of the denominator. So limit x approaches 0. This is product rule. 2x is one term, cosine x square is one term. So 2x derivative is 2, cosine x square remains as it is, plus next time 2x remains as it is, cosine x square derivative is negative sine x square, and x square derivative is 2x divided by 5 tan x. 5 tan x derivative is 5 secant square x. Now plug in 0. What do I get it out? 2 cosine 0 plus 2 times 0. Entire everything is 0. So I have no need to write, or then still you can write sine 0. Again 2 times 0 divided by 5 times secant square 0. Cosine 0 is 1 and 0 times anything is 0. Secant 0 is also 1. So my answer is going to be 2 upon 5. That's going to be the first question. Now we shall go to the second question. So we have a function or a curve equation x square plus y square times y square equals to 4x square, and x is greater than or equal to 0, y lies between negative y and negative 2 and positive 2. Verify about the maximum and minimum points. So what am I going to do that? To get the maximum and minimum points, so first of all I find the derivative. So I'm going to use the product rule. So what is that over there? The product rule is going to be x square plus y square times y square is 1 on the left hand side, and 4x square derivative on the right hand side is going to be the easiest one. So I keep x square plus y square as it is, and y square derivative is 2y dy by dx. Next time x square plus y square as it, then next time what am I going to do? I'm going to find the derivative of x square and y square. So y square as it is, x square derivative is 2x and y square derivative is 2y dy upon dx equals to 4x square derivative. What is 4x square derivative? 8x. So this is u and v. So what am I going to do with that? U v prime and v u prime. So derivative of d by dx of uv will be nothing but what? uv prime plus vu prime. So I have used that formula to get it on the product rule derivative for the left hand side. Next, what am I going to do it out? I'm going to expand that. So when I'm going to expand it out, it becomes, because I want dy by dx common. So this y square times y is 2y cube. So 2y x square plus y square dy upon dx plus 2x square y 2xy square. I'm expanding the bracket, 2x plus y square plus 2y cube dy by dx equals to 8x square. Then what should I do? I take dy by dx common. When I take dy by dx common, I will be getting it out. Further step as dy by dx common. So I get first step as 2y times x square plus y square plus 2y cube equals to 8x square minus 2xy square. Then make dy by dx as a subject. So what does that becomes now? Dy by dx equals to 8x square minus 2xy square upon x square plus y square times 2y plus 2y cube. Now to find the maximum value and minimum value, what am I going to do? I am going to take dy by dx should be equals to 0. So this entire thing, 8x square minus 2xy square upon x square plus y square times 2y plus 2y cube should be equals to 0. Cross multiply, what do I get? 8x square minus 2xy square equals to 0. Then take 2x common. So what do I get it out? 4 minus y square equals 0. So either x equals to 0 or 4 minus y square equals to 0. So y square equals to 4, y equals to plus or minus 2. So, but it has been given in the question that y lies between -2 and +2. So therefore this has been rejected. So only maximum and minimum point is possible for x equals to 0. But what is the condition given in the question? He is asking us to verify maximum and minimum points for x greater than 0. So for x greater than 0, there is no maximum or minimum point, because maximum and minimum point is only for x equals to 0. So what am I going to write it out? I am going to write the answer over here. So x equals to 0, there is a maximum or minimum point. So only possible max or minimum point. Minimum point is when x equals to 0. So therefore, no max or minimum point, no max or minimum point for x greater than 0. That's going to be the answer for this question. Coming to question number 3. So he has given an equation over here, and he is asking that in that equation, cos square x minus 3 sine square x f of x, find the roots. The first question is nothing but what? Find the roots of the equation. So to find the roots of the equation, what am I going to do? That this entire thing should be equals to 0 for the first part. Cos square x minus 3 sine square x equals to 0. So what does that becomes? Cos square x equals to 3 sine square x. Then what am I going to do? Dividing by cos square x on both sides. Cos square x and cos square x. So 1 equals to 3 tan square x. So what does that becomes? Tan square x equals to 1 upon 3. So tan x equals to plus or minus 1 upon square root of 3. Now he has given that x lies between 0 to pi. It has been given that x lies between 0 to pi. So therefore, what is the thing? I have to write the first quadrant and second quadrant. So in the first quadrant, tan x equals to pi 1 upon root 3, and in the second quadrant, tan x equals to negative 1 upon root 3, because first quadrant and second quadrant. According to this, it is in Q1 and Q2. In Q1, tan is positive, in Q2, tan is negative. So this becomes x equals to pi upon 6, and this becomes x equals to 5 pi upon 6. So the roots are pi upon 6 and pi upon 6. That is the first part. Or you can write it as a points, pi upon 6 comma 0 and 5 pi upon 6 comma 0. This is not required, but useful for sketching purpose. That's why we are writing it out. Now coming to the part 2. Find f prime x. He is asking us to find it out, f prime x, in the part 2. So cos square x or cos x whole square minus 3 sin x whole square. So derivative 2 cos x. Cos x derivative is nothing but what? Negative sin x. Minus 3 2 sin x, and sin x derivative is nothing but what? Cosine x. So it becomes negative 2 sin x cos x minus 6 sin x cos x. So totally answer is going to be negative 8 sin x cos x. This is part 2. Now in the next part, what is he asking in part 3? Find the coordinates when f prime x equals to 0. So f prime x equals to 0. So negative sin x cos x equals to 0. So negative 4 2 sin x cos x equals to 0. Negative 4 sin 2x equals to 0. Sin 2x equals to 0 upon 4 is 0. So, but again x lies between 0 to pi. So, what am I going to get that one? Now, I have to get the values of sin 2x. So, 2x equals to sin inverse of 0. Now it is in first and second quadrant. First quadrant and second quadrant. So I write the general solution. 2x equals to n pi plus minus 1 whole to the power of n times alpha. Alpha value is 0. 2x equals to n pi plus minus 1 whole to the power of n times 0. So 2x equals to n pi, x equals to n pi by 2. Now plug in n equals to 0. So I get x equals to 0, n equals to 1, I get x equals to pi by 2, n equals to 2, I get x equals to pi. Now I have to get the values of the coordinates. So therefore f of 0. F of 0, when you do that one, cos square 0 minus 3 sine square 0. This is going to be 1. And over here, f of pi by 2, which is cos square pi upon 2 minus 3 sine square pi upon 2, which is going to be nothing but what? Negative 3. Then f of pi is going to be cos square pi minus 3 sine square pi, which is going to be 1. So what are the coordinates that I'm going to get it out? I'm going to get the coordinates as 0, 1, then pi upon 2, negative 3, and pi, 1. That's going to be the answer for part 3. Now, part 4, sketch the graphs. So we know the turning points and we know the what it is the roots. We know the roots and we know the turning points. Therefore, what am I going to do? I am going to mark them all, and it is between 0 to pi. So this is 0, 0, 1. Then next one is pi upon 6, 0. That was a root. The next one was a turning point, pi by 4, pi upon 4, pi by 2, negative 3 was one of the root. And the next one was 5 pi by 6. 5 pi upon 6, 0 was one of the root. And finally, pi, 1 was another turning point. So this all we know it out. So we are going to draw a curve joining all these. A rough sketch of the curve. The main intention is not the shape. The shape is okay. It can be a rough shape. But the thing is, you should be knowing it out the turning points and the roots. That is about the sketch the graph. Next part. What is the next part being asked? The next part being asked is solve f prime x is greater than or is greater than 1. Absolute value of f prime x is greater than 1. Now, absolute value. So before that, for this, if the graph is asked for absolute value, what am I going to do that one? I am going to draw this negative part as positive part, and it's going to be the same. It is negative 3, so it goes up, and this green color graph is going to be the one if at all absolute value of f prime f of x is being asked. Now this is greater than 1. This graph is greater than 1. So we have to find it out, this particular point and this particular point. So basically what am I going to do it out? I am going to draw the same straight line at minus 1. I am going to draw the same straight line at minus 1 and find those points. It will be the reflection of those points itself only. So my main intention of doing it out this one is find the solution for minus 1. Why am I finding the solution for minus 1? Because its reflection is going to be the same, so the x coordinates is going to remain the same. So find the for the main function f of x equals to minus 1. Then what is the thing? You'll be getting the x coordinates. So cos square x minus 3 times 1 minus cos square x equals to negative 1. So cos square x minus 3 plus 3 cos square x equals to negative 1. So 4 cos square x equals to 2. So cos square x equals to 1 upon 2. So cos x equals to plus or minus 1 upon square root 2. So we got the values of cos x as plus or minus 1 upon square root 2. So cos x equals to 1 upon root 2 and cos x equals to negative 1 upon root 2. So again we know that x lies between 0 to pi, means first quadrant and second quadrant. So this is the first quadrant value and this is the second quadrant value. So x equals to pi upon 4 over here, x equals to 3 pi upon 4 over here. So we can see that between pi upon 4 and 3 pi upon 4, the f prime x is greater than 1. So what is that answer I'm going to write it out? X lies between pi upon 4 and 3 pi upon 4. That's going to be the coming to question number 4. Use L'Hopital's rule for this one. So tan inverse of x, derivative is 1 upon 1 plus x square, 2x whole square. Again 2x derivative is 2, chain rule. Tan x derivative is secant square, 3x. 3x derivative is 3. Now plug in 0, 2 upon 1 plus 0 square divided by 3 times secant square 0. So which is 2 upon 1 divided by 3 times 1. So what is going to be the answer? 2 upon 3 is going to be the answer. Find the equation of the tangent. So when x equals to 0. So what am I going to do? First find the derivative. dy upon dx. E to the power of 2x derivative is e to the power of 2x times 2. Minus 3x derivative is minus 3. Now plug in x equals to 0. So e to the power of 0 times 2 minus 3, which is 2 minus 3, which is negative 1. So the slope is negative 1. Now we need to know the points x and y also. So what does that do? I do for that? Plug in y equals to now e power 0 minus 3 times 0. So y equals to 1 minus 3. So y equals to nothing but what? Negative 1 minus 0, because 3 times 0 is nothing but what? 0. So 1 time 1 minus 0, which is 1 minus 0 is nothing but how much? 1. So what's going to be the point? 0 comma 1 is going to be the point. Now what will be the equation of a tangent? Y minus y1 equals to m minus m times x minus x1. So y minus 1 equals to negative 1 times x minus 0. So what do I get it out? Y equals to negative x plus 1. That's going to be the equation. Coming to question number 6. Show that dy by dx is equal to something for y square equals to sine xy. So y square derivative. What is y square derivative? 2y dy by dx equals to sine xy. Now sine xy derivative. What does that become? Sine xy derivative? Cosine xy. Then xy derivative is a product rule. X times dy by dx plus y times 1. Now I want to make dy by dx as a subject. So 2y dy upon dx minus x times cos xy times dy by dx equals to y times cos xy. So how I got that one? First I multiplied these both and moved to the other side. Then I have multiplied these both and kept it on the same side. So then next, what can I take common? Dy by dx common. So what am I left over with? 2y minus x times cosine xy equals to y cosine of xy. So what does dy by dx now becomes? Dy by dx becomes as y times cos xy upon 2y minus x cos xy. This is going to be the answer for the first part. Now in the second part, what is he asking in the second part? If dy by dx equals to 0, then show that y equals to plus or minus 1 and find the coordinates of what is this? If dy by dx equals to 0. So how should I be able to do? So I got dy by dx equals to 0. What was dy by dx? Y for the second part. Y cosine of xy upon 2y minus x cos xy equals to 0. So cross multiplication, what do I get from there? Y cos xy equals to 0. So what does it become? Because y is not equals to 0, so only cos xy equals to 0. As y is not equals to 0, so only cos xy should be equals to 0. Now we know that sine square xy plus cos square xy equals to 1. So cos square xy was 0. So sine square xy plus 0 equals to 1. So sine square xy equals to 1. So sine xy equals to plus or minus 1. What is sine xy? According to the question, y square. Y square is equal to again, or else y square equals to again 1, because y square equals to negative 1 is not possible. So y square equals to 1. So y equals to nothing but what? Plus or minus 1. That's the answer for the second part. Coming to the third part. In the third part, what is he asking it out? Find the coordinates when dy by dx equals to 0 and between 0 to 4 pi. So what should I be doing it out? We know that y equals to plus or minus 1, and also we know that dy by dx equals to 0. So we are going to take two conditions, y equals to positive 1, y equals to negative 1, and we do the two conditions solving together. Now we know that y square equals to sine xy. So we are going to plug in those values now. So y square, 1 square equals to sine times x times 1. So what does that become? Sine x equals to 1. This is nothing but what? Pi by 2. Now what is the thing is, we have to get it out between 0 to 4 pi. Sine is positive in first quadrant, and what is this? Second quadrant, according to the, what is this? Positive values over here. So now it is sine inverse 1 means it's going to be pi by 2, and add again 360 degrees to that, it's going to be 5 pi by 2. So these are the two values of what is this when it is going to be positive, pi by 2 comma 1 and 5 pi by 2 comma 1. Now the next value, what am I going to take? Y equal to negative 1. So negative 1 whole square equals to sine of x times negative 1. So 1 equals to minus sine x. So sine x equals to negative 1. So x is, sine is negative. Sine is negative in second quadrant, third quadrant and fourth quadrant. Third quadrant is 3 pi by 2. Then add again 2 pi to that, it becomes 7 pi by 2. So it's going to be 3 pi by 2 comma negative 1 and 7 pi by 2 comma negative 1. Those are going to be the coordinates for the values when the first derivative is equals to 0. Coming to the next question, a camera at C is 3 meters from the edge of a straight road. Camera detects car traveling along the road at t equals to 0. It then rotates, always pointing at the car. Car travels at a speed of 24 meters per second. Find d theta by dt in radians per second at a point O when the car reaches point O. So the car is there, it is starting from x and it is going over here in the speed of 24 meters per second. So if this distance is x, so we know that dx upon dt equals to 24 meters per second. Now it is at an angle theta. So we can know that tan theta equals to opposite side upon adjacent side. So x equals to 3 tan theta. If I find the derivative, what does it becomes? Dx upon d theta equals to 3 secant square theta. Now, what else is being asked us to find it out? Is asking us to find d theta by dt. D theta by dt when it is at O. So d theta by dt is d theta upon dx times dx upon dt. What is d theta upon dx? It is a reciprocal of this one. 1 upon 3 secant square theta times dx upon d theta is 24. Then 3 times 1, 3 times 8. So it is going to be 8. 1 upon secant square theta is cos square theta. But he's asking at O. At O, the angle is going to be 0. So 8 cos square 0, which is going to be 8. 8 radians per second. That's going to be the answer. Upon 4, show that dy by dx equals to 2 plus pi upon 2 minus pi at 1 comma 1. So what am I going to do that? I am going to find the derivative. So dy upon dx equals to, this is product rule. X times tan derivative is secant square. Secant square pi xy upon 4 times pi upon 4 again x, y derivative is dy by dx. Then plus pi upon 4 y, x derivative is 1. So what I have done it out? uv prime. So first of all, this is u and this is v. So I have kept u as it is. This entire thing is v prime. In that v prime also, what am I going to consider is pi x is u and v is dy by dx is v prime. So uv prime, and again this will become v times u prime. So derivative of uv prime is nothing but, uv is nothing but what? Derivative of uv is uv prime plus vu prime. So find it out which is u and which is v. Now I have just done only uv prime, so I have to do it out vu prime. So v, what is v? V is tan pi x of y upon 4 times 1, because x derivative is 1. So this is going to be my v and this is going to be u prime. So uv prime plus vu prime. So what am I going to do now? I am going to expand it out. and at 1 comma 1. So easy to first of all plug in 1 comma 1. So dy by dx equals to 1 times secant square pi upon 4 times pi upon 4 times dy by dx plus pi upon 4 plus tan pi upon 4. So secant square pi upon 4 is root 2 whole square times pi upon 4 dy by dx plus pi upon 4 tan pi upon 4 is 1. So what does that becomes? 2 times pi upon 4 times dy by dx plus 2 times pi upon 4 plus 1. So what does that becomes now? I make a space so that it can come in only one screen. So you can clearly refer to that. Pause it and refer to that. So now what does that becomes now? Dy by dx equals to pi upon 2 dy by dx plus pi upon 2 plus 1. So take dy by dx terms on one side. Dy by dx minus pi upon 2 dy by dx equals to pi upon 2 plus 1. Now I move it over here. So dy by dx common, 1 minus pi upon 2 equals to 1 plus pi upon 2. So what does dy by dx becomes now? 1 plus pi upon 2 divided by 1 minus pi upon 2. 1 plus pi upon 2 divided by 1 minus pi upon 2. So what does that becomes now further? Dy upon dx equals to 2 plus pi upon 2 divided by 2 minus pi upon 2. Then 2 cancels, that is the required answer. 2 plus pi upon 2 minus pi is going to be the required answer. For part 2, find the equation of the normal at 1 comma 1. So we know x equals to 1, y equals to 1, and the gradient is 2 plus pi upon 2 minus pi. This is the gradient of the tangent. So gradient of the normal will be equals to minus of 2 minus pi divided by 2 plus pi. So what does that becomes? Pi minus 2 upon pi plus 2. So now what should be the equation? Y minus y1 equals to pi minus 2 upon pi plus 2 times x minus x1. So we can simplify or you can leave it out over there. That's going to be the question number 9. Find the local maximum value or point for this one. So what am I going to do? This is a quotient rule. So I am going to do the quotient rule. What is quotient rule? If I have u upon v, its derivative will be v square, v times u prime minus u times v prime. If I do that way, that will be much more difficult. So rather than, what is the easiest way I can do for that one is separate into fractions. 2 upon 2x cube minus 3x to the power of 5 upon 2x cube. You can do by quotient rule, but this method becomes much more easier. X power minus 3 minus 3 upon 2 x power 2. So you have to find it out the derivative for this one. So what is the derivative of this one now? What does that becomes? It becomes as f prime x equals to minus 3 x power negative 4 minus 3 upon 2 times 2x. And for the local maximum value, the first derivative should be equals to 0. So negative 3x power negative 4 minus 3x equals to 0. So negative 3 upon x power 4 equals to 3x. 3 cancels. Negative 1 equals to x power 5. So what does that becomes? X power of x equals to fifth root of negative 1. Fifth root of negative 1 is going to be negative 1. Now I got the value of x. Now I need to get the value of y also. So y equals to 2 minus 3 times of negative 1 whole to the power of 5 divided by 2 times of negative 1 whole cube. So what does it becomes? 2 plus 3 upon negative 2. What does that becomes? Minus 5 upon 2. So what are the coordinates of the local maximum point, which is a, negative 1 comma negative 5 upon 2. That is the answer for the first part. Now coming to the second part, show that it has only one point of inflection. We have to prove that it is only one point of inflection and it is connected. That point of inflection is written in that form. Find the values of a and b. So for finding that it is having only one point of inflection. So what should I be doing it out? I will be finding it out the second derivative. Second derivative will become 12 upon x to the power of 5 minus 3 should be equals to 0. 12 upon x power 5 equals to 3. So x power 5 equals to 4. X equals to fifth root of 4, which is nothing but what? 2 to the power of 2 upon 5. So there is only one value. We can clearly see that there is only one value for this one. Therefore, there is only one point of inflection. So only one point of inflection. Now that x equals to nothing but what? X equals to 2 to the power of 2 upon 5. Now what has been given in part B? B, the coordinates of the point of inflection as 2 power a, b times 2 power minus 3a. So what am I going to do that one now? I am going to plug in f of 2 upon 5 to get the point of inflection. So f of 2 upon 5, which is 2 minus 3 times of 2 power 2 upon 5 whole to the power of 5 divided by 2 times 2 power 2 upon 5 whole to the power of 3. So what does that becomes? 2 minus 3 times 4 divided by 2 times 2 power 6 upon 5. So which is nothing but what? Negative 10, because 2 minus 12. 2 minus 12 is negative 12, and this is 2 power 1 plus 6 by 5 is nothing but 11 upon 5. So it will become negative 10 times 2 power negative 11 upon 5. This is the value of y, and x value is given as 2 power 2 upon 5, but the x value is given as 2 power a. So 2 power a equals to 2 power 2 upon 5. So a value is 2 upon 5. Now compare it out. For the value of b, it is b times 2 power negative 3a. Negative 3a. So I want it out in the form of negative 3a. So what should I be doing it out? So I cannot multiply over there and keep that as 10, because 11 upon 5 is not a multiple of 3. So what should I be doing it out? Rather than writing it out over here as 2 power 11 upon 5, what is the correction I will be doing it? I will be writing this 2 times 2 power 6 upon 5, and I can cancel 2 times 1, 2 times 5. I get negative 5 times 2 power minus 6 upon 5. So you can clearly see that it is 2 to the power of negative 3 I take, and 2 upon 5. Minus 6 upon 5 can be written as negative 3 times 2 upon 5. So it is in that form. Which form it is that in that? It is in the form of b times 2 power negative 3a. So a is 2 upon 5, which is valid over here. So what is the value of b? B equals to negative 5. If I write it as 11 upon 5, you can clearly see that it cannot be written in that particular form given in the question. So therefore, I don't simplify it, rather than keep it as it is. Now, coming to the last part, he is asking us to sketch the graph. So how should I be able to sketch the graph? So for sketching the graph, I take x-axis and y-axis over here, and what all we have done it out. We know that it was the maximum point. A having a maximum point. What was the maximum point of A? Negative 1, negative 5 upon 2. There was a negative 1, negative 5 upon 2 was a maximum point, and there was a point of inflection at 2 power a, which is 2 power 6 upon 5, and negative 5 times 2 power minus 3a. That's going to be the inflection point. And anything else is given, that's all. So local maximum point at this one means only this is the way we can do that one. And inflection point means it keeps on decreasing or increasing from there. This is going to be the inflection point. So In this way, the sketch of the graph can be done approximately because we have a local maximum point and a inflection point at B. Coming to the next question, find the coordinates of P where the tangent is parallel to y-axis. So find the derivative first. So what is that? X cube derivative 3x square plus 3y square dy by dx minus uv prime 3x dy by dx minus 3y equals to 0. So what do I take? 3x square minus 3y equals to dy by dx to the other side. It becomes 3x minus 3y square. So what do I get from there? So what do I get dy by dx as? I get it as 3x square minus 3y divided by 3x minus 3y square. Now the tangent is parallel to y-axis. Tangent is parallel to y-axis means the denominator, what it says, what should be the dy by dx? Dy by dx should be equals to 1 upon 0 means denominator equals to 0. 3x minus 3y square equals to 0. So what does it becomes? X equals to y square. Plug in that x equals to y square in the question. So it becomes y power 6 plus y cube minus 3y cube equals to 0. So y power 6 minus 2y cube equals to 0. Then apart from that, then I try to simplify it further. So y cube common. So y cube minus 2 equals to 0. So y cube equals to 0 or y cube equals to 2. But y equal to 0 is not possible. So therefore y equals to cube root of 2. Y equals to cube root of 2. So therefore I get the value of y as cube root of 2. Then I need to get the value of x also. So x is going to be y square, which is cube root of 2 whole square. So x equals to 2 per 2 upon 3, or it is 4 per 1 upon 3. So what are the coordinates now? The coordinates are going to be cube root of 4 comma cube root of 2, the easiest way to write it out. Coming to question number 11, verify whether this function is an even function or an odd function. For verifying the function is an even function or an odd function, we have to plug in negative x. When I plug in negative x, it becomes cos of negative 2x times cos of negative 4x times so on cos power negative 2 power n x. So we know that cos of negative x is going to be nothing but what? Cos x itself only. The negative value does not have any effect at all. I get cos 2x, cos 4x, and so on cos 2 power n x. So we can see that it is same as fn of x. It's going to be the same function. When it is going to be the same function, therefore it is an even function. So negative value does not have any effect. It is an even function. Now part B. In part B, what am I supposed to do? Use mathematical induction to prove that. So first of all, we have to use the basis. So I'm going to use the basis step for this one. Basis means n equals to 1. When I'm plugging n equals to 1 for n equals to 1. Let P of n will be the statement, okay? So let P of n is going to be our statement. What is that statement? So that's all. We have to write it out clearly over there. Let the P of n is going to be our statement. Fn of x equals to sine 2 power n plus 1x upon 2 power n sine 2x. And x is not equals to n pi by 2 and m belongs to z. M pi by 2 and m belongs to c. So let n equals to 1. So let n equals to 1, what does that becomes? N equals to 1, f1 equals to cos 2x. I have only cos 2x, whereas that will be equal to cos 2x. I multiply and divide with 2 sine 2x. 2 sine 2x. So what do I get it out? Sine 4x. Sine 4x upon 2 sine 2x. So when I get sine 4x upon 2 sine 4x, you can see that when you plug in n equals to 1 in the statement also, I'll be getting the same answer. So therefore, P of 1 is true. That is the first step. Next, what am I going to do? I am going to do the assumption. What do I assume? Assume cos 2x plus cos 4x, cos 2x times cos 4x, and so on, cos to the power of 2 per cos 2 per k plus 1 x equals to sine to the power of sine 2 to the power of k plus 1x divided by 2 power k sine 2x. This is our substitution. Now what am I going to do? I have to prove that it is true for n equals to k plus 1. So p of k plus 1. This is p of k is true. P of k plus 1. For that, what I'll do? F of k plus 1 x is nothing but what? F of k times cos of 2 power k plus 1 x. So f of k we have already assumed as sine 2 power k plus 1 x upon 2 power k sine 2x times cos 2 power k plus 1 x. Next, what should I be doing it out? Multiplying and dividing by 2. So that the numerator becomes 2 sin a cos a sine 2a. Sine of 2 times 2 power k plus 1 x divided by 2 power k sine 2x. So what does that becomes now? Sine of 2 power k plus 2 x divided by 2 power k plus 1 sine 2x. So we can see that it is clearly satisfies. So p of k plus 1 is true. If p of k plus 1 is true, so what we can do? Write the conclusion. By induction, principle of mathematical induction, p of 1, p of k and p of k plus 1 holds. It implies p of n is true for all values of m belongs to z plus. That's going to be the answer. N belongs. This was n. N belongs to z plus. That one was for mathematical induction. Now the next part of the question. What is the next part of the question? It says find the first derivative and find the equation of the tangent. Those two are interrelated to each other. So coming to the next part of the question, find the first derivative. So f of nx is nothing but what? 1 upon 2 power n times sine 2 power n plus 1 x upon sine 2x. So this is quotient rule. So 1 upon 2 power n will remain as it is. Then I write sine 2x times 2 power n plus 1 times sine derivative is nothing but what? Cosine. Cosine 2 power n plus 1 x minus next time sine 2 power n plus 1 x will remain as it is. Sine 2x derivative is nothing but what? 2 cosine 2x divided by sine square 2x. So we can leave it off over here. No need to simplify it further because he did not ask us to simplify. And coming to the last part, what was he asking? He was asking us to find the equation of the tangent. So for finding the equation of a tangent, I need to know the slope. So at equation of a tangent at any another point has been given at x equals to pi upon 4. So what am I going to do? I am going to plug in pi upon 4 in this derivative. So m equals to 1 upon 2 power n sine 2 times pi upon 4 is sine pi by 2, 2 power n plus 1 cos 2 power n plus 1 times pi by 4 minus sine of 2 power n plus 1 times pi by 4, then 2 cos of pi by 2 divided by sine square pi by 2. I plugged in wherever x is there, pi by 4 I have plugged in. Now, very carefully see that how do I simplify this one. 1 upon 2 power n, sine pi by 2 is 1 times 2 power n plus 1. This can be written as 2 power n minus 1 and plus 2. So, what is that, right? 2 power n plus 1 times pi by 4. How do I simplify 2 power n minus 1 times 2 square times pi by 4? So that what will happen? 4 gets cancels. This entire thing will become 2 power cos of 2 power n minus 1 pi. Cos of 2 power n minus 1 pi minus 2 cos pi by 2. Cos pi by 2 is 1. Then again, same thing, it can be written as sine 2 power n minus 1 times pi divided by sine square pi by 2 is 1. Now why am I writing it out like that? Because we see 2 power n minus 1 pi. 2 power n minus 1 pi for cos. Cos 2 power n minus 1 times pi is always equals to 1, and sine for any value of n. Sine 2 power n minus 1 pi will be always equals to 0. You can plug in any value of n and check it out that if at all it is a 2 power n minus 1 multiples of pi, it is going to be 1, whereas sine all multiples of pi is going to be 0. So I can easily simplify it further. So it will become 1 upon 2 power n times 2 power n plus 1 times 1 times 1 minus 2 times 0 divided by 1. So what am I going to get it out? 2 power n plus 1 upon 2 power n. So which is going to be 2. So the gradient is going to be 2. Now I know x value is pi by 4. I need to get the y value also. So f of pi by 4 equals to sine of 2 power n minus 1 times pi, the same process, divided by 2 power n times sine of pi by 2. I plugged in pi by 4 over there. So again we know that 2 power n minus 1 times pi is always, multiples of that one will be always going to be 0. So 0 by anything is 0. So then I use y minus y1 equals to m times x minus x1. So y minus 0 equals to 2 times x minus pi by 4. So y equals to 2x minus pi by 2. Then I further multiply it out. 2y equals to 4x minus pi. So 4x minus 2y minus pi equals to 0. So find an expression for dy by dx. So what am I going to do? Find the derivative. 3x derivative is going to be 3 minus 2y. This is uv prime. So product rule. 2y square derivative is going to be 4y dy by dx times e power x minus 1 minus next time 2y square as it is, e power x minus 1 derivative is e power x minus 1 equals to 0. So 3 then minus e power x minus 1 I take common. So it will become 4y dy by dx plus 2y square equals to 0. So what do I get it out? 3 equals to e power x minus 1 times 4y dy by dx plus 2y square. So 3 upon e power x minus 1 equals to 4y dy upon dx plus 2y square. So 3 times e power 1 minus x equals minus 2y square equals to 4y dy upon dx. So what will be dy by dx now? Dy by dx equals to 3 times e power 1 minus x minus 2y square divided by 4y. That's going to be the answer. And last part, what is he asking over there? He is asking us to find it out the equations of the tangents at x equals to 1. So how am I going to do that one? So I am going to plug in, substitute x equals to 1 in the original equation. So when I substitute x equals to 1, so 3 times 1 minus 2y square e power 1 minus 1 equals to 2. So 3 minus 2 equals to 2y square. So 2y square equals to 1, y equals to plus or minus 1 upon root 2. So now I am going to find it out dy by dx, the slope at that particular point. So which is 3 e power 1 minus 1 minus 2 times, because it is y square, even though I take plus or minus 1 by 2 does not make any difference at all. Then divided by 1 time I take 4 plus 1 upon 2. 2 times plus 1 upon root 2 whole square divided by 4y. So when I simplify that, what do I be getting it out? It is 3 minus 1 divided by 4 upon root 2. So which is 2 root 2 upon 4, which is nothing but what? Root 2 upon 2 if I take positive value. If I take the negative value the same way, 3 e power 1 minus 1 minus 2 times minus 1 upon root 2 whole square divided by 4 times minus 1 upon root 2. So same answer is going to be getting it as minus root 2 upon 2. So my slope is either plus or minus root 2 upon 2. Then my equation of the tangent, y minus y1 equals to, if for the positive value, positive root 2 upon 2 times x minus x1. So y minus 1 upon root 2 equals to root 2 upon 2x minus again 1 upon root 2. 1 upon root 2, 1 upon root 2 gets cancels. Y equals to 1 upon root 2x, because root 2 upon 2 is 1 upon root 2. Now when I take the negative value, y plus 1 upon root 2 equals to minus 1 upon root 2 times x minus 1. So y plus 1 upon root 2 equals to minus 1 upon root 2x plus 1 upon root 2. So again they get cancels, y equals to minus 1 upon root 2x. That's going to be the answer. See you in the next video. So this is question number 14. It is asking find the height of the ball above the ground when it is released. When it is released means the time has to be 0. The starting time has to be 0. So therefore I plugged in t equals to 0. Cosine 0 is 1. So 0.4 plus 1.8, which is 2.2 meters. So when it is released, it is 2.2 meters. That's going to be the answer. Now, next part of the question. What is the next part of the question? Find the minimum height. He's asking us to find it out the minimum height. So how should I be finding it out the minimum height? So what is the equation that we have? We have the equation h of t equals to 0.4 cos pi t plus 1.8. Now the minimum height. The minimum height will be whenever the cosine will be having the minimum value. Cosine minimum value is -1. So because it all depends upon the cosine function. So cosine function has a minimum value as -1. So it's going to be negative 0.4 plus 1.8. So which is going to be nothing but how much? 1.4 meters. That's going to be the answer. Is the minimum height. Coming to the next part. Show that it takes 2 seconds to return the ball to its initial height. So we have to show that it takes 2 seconds to return the ball to its initial height. So we will know that the ball is released from the maximum height and it returns there a period later of this cosine pi. What was the period of this cosine pi? Cosine pi t, its period. It completes one full cycle. So we have to talk about the period. So period of that one is going to be nothing but how much? 2 pi upon pi, which is nothing but what? 2 seconds. So because it completes one full cycle to come back to its original height or the maximum height. So that's why we are going to talk about the period, which is 2 pi by 2 pi divided by pi. Pi and pi gets cancels. 2 seconds. For the first 2 seconds, find amount of time ball is less than 1.8 plus 0.02 square root of 2 meters above the ground. So for that, equate that. Equate the equation. What is the equation? 0.4 cos pi t plus 1.8 should be equals to 1.8 plus 0.2 square root 2. So 1.8, 1.8 gets cancels. 0.4 cos pi t equals to 0.2 root 2. So cos pi t equals to 0.2 root 2 divided by 0.4. So cos pi t equals to root 2 upon 2. So pi t equals to cos inverse of square root of 2 upon 2. What is square root of 2? It is pi upon 4. So pi t equals to pi upon 4. And next, again, it is positive in the fourth quadrant, which is again nothing but what? 7 pi by 4. So two values, either pi by 4 or 7 pi by 4. So t value is going to be nothing but how much? 1 upon 4 or 7 upon 4. Why am I taking like that? Because we know that t lies between 0 to 2 seconds. So that's why we are taking it out in two different quadrants. So this is in quadrant 1 and this is in quadrant 4. So therefore, it's going to be at 1 upon 4 and 7 upon 4. So what is the difference between them? 7 upon 4 minus 1 upon 4. So this is nothing but what? 6 upon 4, which is 1.5 seconds. So what is he asking in that question? For first 2 seconds, find the amount of time. Find the amount of time. So for part 4, that's going to be the answer for 1.5 seconds. Now coming to part 5. Let me add a page over here in part 5. What is being asked in part 5? Find the rate change of the ball's height when t equals to 1 upon 3. So what am I going to do? We know that h of t equals to 0.4 pi 0.4 cos pi t plus 1.8. So rate change h prime t equals to minus 0.4 sin pi t times pi, because chain rule. Cos derivative is negative sign, and what is this? Pi t derivative is pi, and 1.8 derivative is 0. Now we have to plug in at 1 upon 3. So 1 upon 3 equals to negative 0.4 pi sine pi by 3. Simplify that, you should be getting 0.2 pi square root 3 meters per second. So that's going to be the answer. Now coming to question number 15, g of x equals to e power x squared plus 1. Find g prime of negative 1. So g prime of x equals to e power x squared derivative is e power x squared plus 1 times x squared derivative is 2x. Now what am I going to plug in? I am going to plug in negative 1. So e power negative 1 whole square plus 1 times 2 times of negative 1. So it becomes e power 1 plus 1 times negative 2. So what is going to be that answer? Minus 2 e power 2. That's going to be question number 16. The vertex is 3, 4 for a quadratic. Find the equation of axis of symmetry. So we have basically a quadratic over here. Graph. Let me draw the graph. And the vertex of the graph is going to be 3, 4. So this is 3 and 4. That's going to be the vertex. And he's asking axis of symmetry. Axis of symmetry will be along the vertex itself only. So what will be the axis of symmetry? The axis of symmetry will be x equals to 3. That is the first part. Second part, what is he asking? Convert that one into a vertex form of equation and find the values of h and k. So whenever we know the vertex, then what will be the vertex form? Y equals to a times x minus 3 whole square plus 4. So what is h value? H value is 3 and k value is 4. Next, what is it telling? It passes through point Q, which is Q over here, and 5, 12, and find the value of A. So Q is a point over here. It passes through that point and find the values of A. So what am I going to do? Plug in that one. 12 equals to A times 5 minus 3 whole square plus 4. So 12 equals to A times 4 plus 4. So 4A equals to 8. A equals to 2. That's going to be the answer. Next part, find the equation of tangent at Q. So for knowing the equation of a tangent, what should I be knowing it out? I should find it out the derivative. So first of all, f of x was 2 times x minus 3 whole square plus 4. So I'm going to find it out f prime of x, which is 4 times of x minus 3 plus 0. So now at q is asking, so therefore at x equals to 5, plug in that one, 4 times of 5 minus 3, which is going to be 8. So the gradient is going to be 8. Now the equation will be in the form of y equals to mx plus c, but it is passing through 5 comma 12. So plug in 5 comma 12, 12 equals to 8 times 5 plus c. So 12 equals to 40 plus c, so which gives me c equals to negative 28. So what's going to be the equation of the tangent? 8x, y equals to 8x minus 28. That's going to be the answer for part 4. Coming to part 5, g prime x equals to f of x plus d. Let me write it out neatly this over here. G prime x equals to f of x minus d. Then find the values of d for which the g is an increasing function. So next is part 4. So g prime x equals to, what is it is? F of x minus d. What is f of x? 2 times of x minus 3 whole square plus 4 minus d. Then it should be an increasing function. Increasing function means nothing but what? G prime x should be greater than 0. So this entire thing has to be greater than 0. So 2 bracket x minus 3 whole square plus 4 minus d is greater than 0. So we come to the graph. We can see that this is the graph. This graph is 2x square, 2 times x minus 3 whole square plus 4. Minus d means you are bringing it downwards. Maybe you can bring it out over here, you can bring it out over here, we don't know. We can bring it out to any other extent. But what is the condition? It should be always positive. So therefore I cannot bring it out below the x-axis. So it cannot have more than 4 units. So d should be always less than 4. D should be always less than 4. Otherwise, it will become below the x-axis and it becomes negative. And finally, the last part, what is he asking? Find the values of x when the g is concave up. So for concave up, what is the condition? Remember, second derivative should be positive. So find the second derivative. So second derivative of g of x. So first derivative of g of x was already 2 times of x minus 3 whole square plus 4 minus d. What will be the second derivative? 4 times of x minus 3, and this should be positive. So x minus 3 should be greater than 0. So x is greater than 3. That's going to be the answer. Coming to question number 17, he has given that domain of f is in the range of, what is this? X lies between a to b, and the graph of f prime x is given. Then maximum is at q and t, minimum is at r. Find the value of x when f of x is increasing. So the function is increasing. When will be the function will be increasing? When the first derivative is positive. So we can see that this entire region, the first derivative is positive. So therefore it lies between 0 to p. So the first part answer is x lies between 0 to p, or p to 0. P is on the left side and 0 on the right side. Next one, what is being asked? Find x when f has a local maximum value. What is the meaning of maximum? The first derivative becomes from positive to negative. It becomes from positive to negative. That point is going to be called as nothing but what? Maximum point. Can we see that? Where is it happening? It is happening at origin, because it is positive over here and it is happening negative over here. So therefore x equals to 0. That is the second part. Third part, find x when is having a local minimum. Local minimum. What is the meaning of local minimum? It becomes from negative to positive. Negative to positive. Where can it becomes negative to positive? We can see that at point P. It was negative over here and it was positive over here. So therefore, at x equals to P. Coming to the part 4, find the values of x when fx has a point of inflection. Point of inflection means what should be the condition? The second derivative should be equals to 0. When will be the second derivative will be equal to 0? You can see that it is at this first point, second point, and third point. These are the values q, r, and t. So q, r, t. but we can clear as second derivative is equals to 0 because he's asking us to justify also. Apart from that, there is one thing called as for t. There is a special thing is t. What is the speciality of this t? At t, the first derivative is equals to 0. So t, second derivative is equals to 0 and the first derivative equals to 0. So this is going to be called as horizontal point of inflection, and other two are just only point of inflection. Now coming to part 5, area of f prime and x-axis is 20 and f of p plus f of 1 equals to 4. Find f of c. What is being asked over there? He says that area of the region enclosed by the f prime, which is the derivative of f, and the x-axis is 20. So which is that area he's talking about? This area plus this area is going to be equals to 20. So I'm going to add it out those two areas and equate to 20. So first of all, I'm going to find it out the area of the top part. How do I find the area of the top part? Integral of f prime x dx from p to 0 plus this is f prime x integral of 0 to t f prime x dx. These two areas I'm going to equate it out or add them and equate to 20. But we know that the second part is going to be a negative one, so therefore I'm going to use the absolute value of that one because it's going to be a negative area. So I will be going it out, use the absolute value and equate to 20 over there and try to work on this. So f of x from p to 0 plus basically f of x from 0 to t should be equals to 20. Now plug in that one will become f of 0 minus f of p plus f of t minus f of 0 should be equals to 20. But what we can do it out is, we know that it's going to come as negative answer, therefore I'm going to swap it. I'm going to write it as f of 0 minus f of t equals to 20. So 2f of 0 minus f of p then minus f of t equals to 20. But in the question, it can be clearly seen that f of p plus f of t is being given as 4. So this value, if at all I take common, 4. So 2f of 0 minus 4 equals to 20. So 2f of 0 equals to 24. So f of 0 equals to nothing but how much? 12. So what is the value of f of 0? 12. And I think he's not asking f of c, it is going to be f of 0 only. So what is the value of f of 0? F of 0 is going to be 12. That's going to be the answer.